Hi everyone, this is Kelly Igorova in the Graduate School of Engineering at Northeastern University. Thank you all for joining today's webinar on pursuing your graduate degree in Mechanical and Industrial Engineering. Today's webinar will feature Nader Jalili, who is the Program Director. And before we begin, we're just going to go over some logistics. If you can please turn off your microphone and camera, ensure that your audio is turned up. If you're having any questions hearing, please dial in using your computer settings, but again, ensure that your microphone is muted. You can type your questions in the chat window. We ask that you please don't use the Q&A box. And today's webinar, we have individuals from the admissions team, co-op. We have a student ambassador who will be answering any questions that you might have about the student experience here at Northeastern. And we will be sure to distribute a recording of the webinar immediately following today's presentation. For those of you who are joining, some have been admitted for the spring 2018 semester. Congratulations. For those of you who are still waiting for your admissions decisions, we hope to publish all of those by the end of the week or early next week at the latest. And for those of you who are prospective students, we welcome you and we're excited to introduce Northeastern University to you. If you're looking to apply for the fall 2018, the deadline is January 15th. And we encourage you to try to submit your materials as close to the deadline as possible. We'll begin by giving you an overview of why Northeastern. Northeastern is ranked as one of the top 50 best national universities here in the United States, according to the U.S. News and World Report. We're located in Boston, although Northeastern at large has a number of other campuses around the country. We are most known for our graduate cooperative education program, which provides students experiential learning, which is one of the most unique features to Northeastern University. And we have one of the top career services nationally. So without further ado, I will hand over the microphone to Nader, who will give you a presentation.
Thank you very much, Kelly. This is Dr. Jalili, Associate Professor and Associate Department Chair for Graduate Studies and Research. I'm here to present to you the Mechanical Industrial Engineering graduate programs that we offer. As mentioned, this is a very exciting time for Northeastern and especially for the college and our department to be involved as we are rapidly growing and expanding our programs in different areas. So I'm hoping you will consider Northeastern, especially our department for future graduate programs. As I go through this, I will try to mention some of the highlights. As currently mentioned, our mechanical engineering PhD program is ranked number 39 in the nation, while our industrial engineering is ranked number 32. The entire College of Engineering, that is actually made of 5 different engineering departments, is ranked 39. University as a whole has been ranked top 50 in the last 4 or 5 years, and I think this year has been ranked 39-40 as one of the best colleges in the nation. We are also a top-tier co-op in the U.S., always ranked number 1 or 2 for our undergraduate and graduate co-op programs. Our undergraduate population, it's about 1,300, and the same amount for the graduate programs students. So this is a very large number, and we are happy to share a lot of excitement from our current students and also faculty who actually advise these many students. There are about 160 PhD students currently enrolled in our department. The department has 55 tenured or tenure-track faculty members, which include 2 National Academy of Engineers. This is the highest stature earned by a faculty member in engineering discipline, and we have actually 2 of them in our department. We have also, in addition to our 55 tenure track faculty, we have about 20 teaching and co-op faculty who are helping the department in that aspect. So with a total of about 75 faculty on our department, I think we are one of the largest mechanical industrial engineering department in the nation. when we compare ourselves with other universities. Our annual research expenditure is about 13 million per year, and we have just received about 125 million contract for healthcare engineering research, plus another $20 million for Army Research Lab to do research in material science and other disciplines. We're going to go over the research clusters in the next few slides, so I will hold off on that until we get to the other slide. So our vision for graduate programs is basically graduating and educating the graduate students in the fundamental principles and practice of mechanical or industrial engineering. So through the basic and applied research done by our faculty and the students, we would like to contribute to the advancement of the body of the knowledge used to industry and government of the state of Massachusetts and also nation and the world. And we are partnering with a lot of entities, companies, and also other factors to bring to you the best education. So this slide shows you almost all the faces in our department, including faculty member, staff, co-op faculty, and also the teaching professors I mentioned. So this list or faces are almost above like 75, 80 people who are exactly doing what they're supposed to do, and plus provide the best education for both undergraduate and graduate programs. I encourage you to look at our MIE website, which is shown here, www.mie.neu.edu. Will list all the important facts about the department, about the degrees and programs and co-op, as well as faculty and the research that you can explore at your own. But just to make life a little bit easier for you, I would like to go through a couple of programs and research clusters that we have in the department. So our faculty are grouped into several groups. These are research/educational groups. The first group, that is the largest group in the mechanical engineering, is called Mechanics Group. The Mechanics Group deals with contact mechanics, including adhesion, friction, plasticity, and modeling of materials, multifunctional composites, MEMS, macro-electromechanical systems, basically assistive technologies, energy harvesting, and a lot of modeling and simulations of nanoscale mechanics. So we have about 15 to 18 faculty members in the mechanics group, and the slide that you're seeing is basically a sample of some of the research of our faculty. Most of these are accessible from our MIE website, and you can go into each of the faculty website and then find out more information and recent papers or grants and even PhD and master students information. Again, this is the mechanics group. The next group in the department is dealing with mechatronics, basically the dynamic systems and control area, which includes also robotics. Robotics is becoming a major player at Northeastern, and the MIE department is also playing an important role in this area. So we have 4 or 5 faculty already involved in the robotics research and also representing the university as a whole. Some of the research areas in this group includes soft robots, basically transformable robots, self-folding mechanics and machines, piezoelectric-based sensors and actuators, vibration control, also control and manipulations at the smaller scale like macro and nano scale. We also work in the area of control systems, looking at the dynamical systems with delays, like network systems, control systems, aided human-machine systems, and also talking about a lot of systems biology. We also do work in human-safe robots and medical robotics and soft robotics, again, as I mentioned, and a lot of bio-inspired design in this group. The next group goes to the thermofluids area. So this is also one of the largest gain groups in the mechanical engineering program that deals with the basically combustion of solid fuels and also talk about fluid dynamics, microfluidics, chaotic mixing. We also have extensive laboratories in fluid mechanics and mechanics of multi-phase transport phenomena. In other areas, our faculty are looking at the energy-related studies and looking for simulations of thermal effects on laser beam, as well as, for example, streaming microorganism formations and development of biofilms and a lot of nonlinear dynamics and chaotic behavior. So the thermofluids group, next slide continues with other basically faculty, representative faculty, fundamentals of combustion, both experimentally and theoretically, are also happening in our department. We also do a lot of work in energy and gas turbine cooling technology, and including also characterizations and subsurface of filtration. So the last group in the mechanical engineering is materials group. This group is also a relatively large group, close to 12 faculty in the department. Some of the sample research are highlighted here. This group is concerned with nano engineering and nano and macro contaminations control for a lot of solidification processes, droplet-based materials, a lot of biomechanics, material science, and structural property relationship in composite and ceramic materials. Also, we have also several faculty members looking at the economic and environmental assessments of both nano and macro manufacturing. They are also looking at the societal impact of nano manufacturing, which has to do with the development and assessment of educational programs for K-12 students. So we are now continuing with, again, materials group, again, one of the largest groups in the department. This slide talks about some of the other research that these faculty are involved with, like engineering magnetics and electronic nanomaterials, nano optics, and a lot of computational techniques that span from multi-scale, from atomic to a continuum to larger scale structures. We also deal with advanced manufacturing and looking at the bio-inspired materials for manufacturing. So we are now moving into industrial engineering. So the industrial engineering program, it's by its own a degree granting program. We're going to talk about this in a few minutes, but so therefore, for that reason, our department is also housed to IE faculty, which are about 20 to 25 faculty. Some of the representative examples of the research are highlighted here, for example, in operation research, data analytics, healthcare, and supply chain manufacturing system. We also have a very big activity in healthcare process improvement and healthcare system engineering. Professor Benyan, for example, is the director of healthcare systems engineering with lots of funding and activities in that area. So we are probably number one in the state of Massachusetts on the healthcare system engineering, bringing a lot of expertise into the department. We also look at simulation optimizations and also design and management of larger scale networks. Also, we look at the supply chain design and network collaboration. In other areas in industrial engineering, faculty are looking at the system's reliability and looking at the big data-driven decision making. Also look at the live data, for example, survival of data, and also robust designs of experiment. We also do work in green manufacturing, green supply chain, and a lot of, as I mentioned before, advanced models for health management using physics-based models and data analytics. We also have people in industry looking at the biomechanics and motor control and healthcare systems and human factors in general. Continue with the industrial engineering. Human-machine interaction. It's a subject that cross-cuts between the two programs within the ME and IE programs. For example, Professor Lin is involved in both programs, both IE and ME, looking at the human-machine interactions and interface design and also user experience, bringing systems integrations from mechanical to human subjects and human interactions in the industrial engineering and human factors in the industrial side of it. We also have other faculty who are looking at the operation research and multi-criteria optimization in the IE program. So the department has 9 research areas, as you're seeing on this slide, that are available in our website. I don't want to go through each of these in detail, so I just want to highlight their title. So the department has formed 9 clusters of research. 75 of our faculty are actually forming these 9 clusters and involving one or more of these areas. So it would be good for you to look at each of these research areas and look at who's working in what area, and then you can find more information about the faculty who are involved in any of these areas. You can also find out about the descriptions of these areas and what they're actually involved with. So, for example, biomechanics and soft matters is the first cluster area. The second one is energy systems, healthcare systems, high impact phenomena like materials domain, that they're looking for materials that they can withstand high impact and high force applications. In the next one, we're looking at the mechatronics and systems that include control, robotics, and human machine. Multifunctional composite, multi-phase structured matters, and also resilience systems. And last but not least is the smart and sustainable manufacturing. So I encourage you to look at these areas when you get a chance. So basically, as you probably know, a lot of interdisciplinary research initiatives are happening in different institutions and different part of the world. Mechanical industrial engineering departments are still assumed or considered to be the traditional departments, but we are a traditional department, but at the same time doing interdisciplinary research initiative that you just saw some of sample. So starting from enabling technology to societal teams to get to use inspired engineering research. For example, you saw advanced nanotechnology in our faculty. You saw modeling and interface and computing, for example, in materials, and you look at a lot of engineering decision making for industrial applications. These become themes that university is pursuing, like in health, security, and sustainability, that will lead to use-inspired research. For example, healthcare engineering in IE, security and sensing and surveillance systems, and also automated intelligent infrastructure for sustainability and security. At the same time, engineering materials for sustainability. So this is basically the theme for the department to still be one of the traditional departments in the nation, at the same time doing exciting and use-inspired engineering research that will impact the society at large. These are some of the highlights of our faculty who have received recently funding for different from different agencies. Professor James Binion is the Director of Healthcare Engineering Systems in our department, and he just recently received funding from National Science Foundations to validate opioid crisis epidemic engineering solution. Our department chair, Professor Hong, started a company called MesoGlue, which he founded with two of his PhD students, and recently received one of the best, coolest inventions of the 2016. Professor Scheffelbein was also recently awarded a National Science Foundation grant for joint and manipulating limbs. Her project is on bone, basically modeling and trying to regenerate limbs from different synthetic materials. Professor Liu was recently awarded a 500K National Science Foundation Career Award on ultra-fast all-optical manipulations of hybrid metal ferromagnetic structures. These awards are the highest award at the National Science Foundation given to a very few select faculty in the nation who are the future scholar of the nation, and giving this award to Professor Liu is an indication of his ability to attract such competitive funding. Professor Martinez was also awarded the same career award from NSF for his research on sensing and imaging research. Professor Erb also again received one of the most competitive awards in the Massachusetts called Mass Challenge 2016, and received the first place for actually creating a solution or a company called 3D Fortify, which was actually funded by himself and one of his PhD students. And lastly, Professor Luis was also a Fulbright U.S. Scholar Program grant for a research in Spain and working in his research on magnetic materials. The university recently built one of the, I think, most excited building in the nation called Interdisciplinary Science and Engineering Complex, or ISEC. This 220,000 square foot facility has basically helped transform the university's research by providing a state-of-the-art structures and also fostering collaborations between the disciplines. For example, robotics research is housed in this building that brings people from different departments like biology, mechanical, industrial engineering, and also electrical engineering and computer science. So this building is now one of our featured building and selected as one of the most advanced or true way of integrating science and engineering in the nation. So we also work with defense and other agencies. For example, Costas Institute is housed in a new facility at Northeastern Burlington campus, which is basically the Center for Research in Advanced Resilience and Security, funded by the Department of Homeland Security. And this also center has both unclassified and classified research for a lot of use-inspired research for both communities, critical systems, and also for military application. So now we're going to the part of the presentation, which is the graduate programs in the MIE department. Just to give you a quick overview of who are the people running the department, as you probably heard about Professor Hung, who's our department chair, Professor Melikarinus, who's the associate chair for the IE program, and Professor Golson, who's the associate chair for the ME program. Both of these are undergraduate programs, and I'm the associate chair for the graduate programs for both ME and IE. programs. As the program directors, I do a lot of things. My office hours actually are posted on our website, so if you look at the website, you will be able to find it. I do oversee all the graduate affairs from admission, recruiting, like today's webinar, and also a lot of assignments and graduation clearance. We do also administer the PhD qualifying exam. I'm helped by Miss Sarah Baluti, who is the Graduate Affairs Coordinator in the department, and her information is also available on our website in case you want to contact regarding any of your admission inquiries. So let me just go through this slide very quickly so to make life easy for you. Basically, we have programs and concentration. So the first thing we need to understand is the difference between a program and a concentration. So a program is a degree granting basically diploma. So when we say program, means that your diploma will say mechanical or industrial engineering. So we offer both PhD and MS degrees in ME, mechanical engineering program. We also offer IE, industrial engineering program, for both PhD and MS degrees. We also offer operation research program, and that's only master's degree. We have now several other new master's programs that we offer. Again, these are all called programs, like data analytics engineering, which is only the master's program. We have some other programs that are already existing or actually coming soon. For example, interdisciplinary PhD, which is run by the college, requires 2 departments involvement. So this is already in place. So if you're interested in interdisciplinary PhD, you have to find a home or the house, basically the department, and then the second department or third department will have to be involved as well. So there's a process for finding or applying for that program in the application package. There is a PhD in materials engineering that is actually at the proposal stage. We're going to probably have that in the next year or so. And then also we have an MS in human factors. We also have an MS in robotics. These are all programs that will be in the works and will be available sometime soon. So now we go to the concentration. So mechanical engineering program, as I mentioned before, has 5 concentrations. The first is general mechanical engineering, mechatronics, material science, mechanics and design, and thermofluid engineering. So that means that when you apply to our mechanical engineering program, you have to select one of these 5 concentrations. There is no other option. When you select any of these concentrations, you will be directed and advised by the appropriate program advisors, as well as clear for graduations for these programs. So each program has different curriculum and different coursework, so you have to follow that. In the industrial engineering program, we have only 1 program, so there is no concentration in industrial engineering. Same thing for operational research, as I mentioned before, is just a program, has no concentration. And then the same thing for the data analytics program, which is only a program and no concentration. With this, we have also concentrations for PhD students, but the problem is that the PhD students do not have an official concentration. They only use this concentration in 2 places, which I'm going to explain this in a minute. But our program actually are either PhD in ME and PhD in IE with no concentrations. The other master's programs, as I mentioned before, for example, ME will have MS in mechanical engineering with the concentrations in thermofluid engineering, for example. But in the PhD, we are not using concentration officially. We're only using in 2 places when you apply to the program in order to channel your application properly to the appropriate academic advisors, and also when you're trying to take the qualifying exam while you are students here. So except these 2 places, the concentrations are not going to be indicated in your transcripts or in your diploma. But concentrations for master's students is a must, as I mentioned before. So you either have to be in a concentration program or you have to be a program that doesn't have a concentration in an MI. And this is used for properly selecting your core courses and clear for graduation. Students can change the concentrations, but not in the first semesters. After proper submissions of a form and obtaining a minimum GPA of 3.2/3.3. That's basically a B plus, and a new application to be reviewed by the respective academic advisor. So we do not encourage students to change their concentration in the first semesters. We would like them to wait for a semester or so, and then decide if this is the right things for them to do. We have 7 graduate advisors in the MI department. Each one is responsible for each of the concentrations / program. For example, material science engineering is Professor Ando. And by the way, all of these names and the contact information are on our website. Mechanics and Design, Professor Viziri; Mechatronics, Professor Sipahi; Thermofluids, Professor Taslim; Industrial Engineering as a whole is Professor Organ; Data Analytics, Professor Kamarti; and the Operation Research, Professor Kronidis. So these are the 7 advisors for the concentration or the program in the department. Let me go over very quickly about the master in the MIE department. In both ME and IE, we have a relatively simple process. So we have 3 tracks or 3 options. The first option for a master in ME or IE is thesis option. This is required for all the teaching assistant or research assistant students. So we're going to talk about this later on. But if you are working with the faculty and the faculty has a funded research, they can fund your study through a research assistantship. Typically, teaching assistantship will go to PhD students, so we will not offer TA positions to master students. But in rare cases, that has been given, but that has to be justified because most of our courses require you to have a master's degree in order to be either in the classroom or helping in the lab with the TA activities. But being an RA research assistant is a possibility. But if you are not any of these, you still can select this option. So for this option, you will take 6 courses. Each one is 4 semesters hours. That's 24 semester hours. Then you take a master's thesis, which has 8 semesters hours, and a technical writing and research seminar that they are 0 semester hours. These are basically very light courses of few classes a semester, and or just sitting in a research seminar to listen to several speakers and write a short summary of their talks. So they are very light courses, and that's what they are 0 semester hours. So 8 and 24, you obtain 32 semester hours, and you can finish this in about 2 years. The next option is that a lighter research as compared to the thesis option, which is called project option. So in this case, instead of 6, you take 1 more courses, and you take 7 4 semester hours of courses. That's 28 semester hours. And instead of the thesis, you take a project. And you still take the technical writing and research seminar, as I mentioned before. So 4 plus 28 again becomes 32 semester hours. And this could take a little bit shorter because of the smaller scope project. If you don't want to do any of these, you take typically what we call it coursework only option, which you take 8 courses and basically finish this in about 1.5 years. All of these options are selected after you become a student. You cannot select this at the beginning. Once you are admitted and advised by the advisors will let you know if you are interested in any of these, what to do. And basically, for the first 2 options, you have to find research advisors who's willing to direct your thesis or project. That means that you have to find a champion. For the last one, which is taken by mostly all of our students, about 80 to 90% of our students select the coursework only option. You do not need to do anything. You just simply follow the core course requirement and the elective requirements for taking your 8 courses. So for MS and PhD, as I mentioned before, if you do a thesis or project option, you will take 2 0-credit hour courses. One is called technical writing, and the other one is research seminar. So these are here to help you for your writing and also for your research, because it's important to know how to research subjects or basically find resources for writing a good thesis or project. And then part-time students can petitions to waive the requirement, as well as students in BSMS program. So I'm going to go over a sample program for one of our concentration. So let's look at the MS in mechanical engineering with concentrations in the mechatronics. For example, if a student select the coursework only option, the program requirement says that you have to take a math course. The ME 6200 or ME 6201 is the math course. So they take either one, and then they will take 3 elective courses, 2 other required courses, for example, control and mechatronics, and then another option for 2 of our easy courses. When you finish this, you're done with 5 basically courses, and then you have selected an elective from one of the options. So this would be the very simple program for students taking that path. Again, 1 math course, 1 control course, 1 mechatronics course, that's 3, for example, 1 EC course, that would be 4, and then 1 combined mechanics course, that would be 5, and then you have a choice of 3 elective courses from any engineering or science programs. We provide a course plan for all the entering students. This is an example of a plan for students who's admitted, for example, in fall of 2016. And by the way, these courses repeat, so this could be applied to any entry point. For example, if you're entering in the fall 2018, the same courses will be offered. So, for example, the first semester you take a math course, dynamics and vibrations. The second semester you take a control and a robotic course. Next fall you take a mechatronics course, and then maybe an advanced vibration, and then you keep continuing with your electives. So, a very simple plan would be drafted by your advisors as soon as you are admitted to the university. So we have 2 advisors for you. If you are a non-thesis MSc student, you are advised by the academic advisors. And this is the 7 people I mentioned in the previous slide. If you select a thesis option, then you will have to have a research advisors who would be your advisors. So therefore, your research advisors will tell you what to take, what not to take, and then academic advisors is just there to make sure that you're clear for graduation. So again, non-thesis will have 1 advisor, thesis will have 2 advisors, 1 research, 1 academic. And if you cannot find your advisors in the first semesters, you're advised by academic advisors who would be your concentration advisors. And then once you find out research advisors, your research advisors will take over. Let's go over those who are interested in our PhD program. Our PhD program has 2 tracks. The first track is coming or accepting with the BS. We call this direct or regular PhD. So for this, you just need your bachelor degree, and you can be admitted to the PhD program. For this, it takes about 5 years to get both MS and PhD at the same time, or what we call it direct PhD without a master's involvement. For that, you take 12 courses of 4 semester hours. That's 48 semester hours. You can also come with the master's degree, which we call it advanced entry, and that takes about 4 years or so. And this program or this track has almost half of the previous track. So you take 6 courses of 24 semester hours. There are no core course requirements for our PhD program. There are no certain or specifics in the courses. All the courses are selected by your research advisors or academic advisors if you don't have a research advisors. But mostly all PhD students should have a research advisors. Otherwise, that PhD doesn't make any sense. In addition to coursework requirement, you have to go through a PhD qualifying examinations, which has a comprehensive written part and an oral exam. Once you pass all the required courses and the qualifying exam, you become what we call a PhD candidate. And then once you become a PhD candidate, you would propose your dissertation, and you take these dissertation courses. These are basically your research courses, and then you defend from your dissertation and graduate. So I will encourage all of you to take a look at our graduate catalog online, which is I think free to public. So you won't be able to find this in that website. Even if you forget that website, all you have to do is just type Northeastern Graduate Catalog with a space or without a space in Google, and it will find this URL for you. So once you get into that website, you should be able to look at all of our programs categorized in degree or slash programs. Very nice and easy to find. There are also a list of all courses, all graduate courses that we offer, whether offered or on the book. So there will be a good number of courses that you can find them. So I will encourage you to look at the course requirements for your selected degree program. At the graduate basically program, we have a lot of events, not just basically going to the classroom and doing hard stuff. We also celebrate our students' accomplishment. For example, in mid-December, we have a departmental research poster expo and engineering as art competition, where students actually compete in poster presentations of the research, and also sending some artistic photo or drawing or art as their research. We're going to talk about and see some of those later on. We also have a presentation of the highest research and teaching accomplishments in the latest spring every year. These are, for example, some of the selected students in getting different awards at the department level. We also, during the events, provide a lot of social networking, food, and the students enjoy networking and talking to their classmates, and also receiving a lot of good information about the department and on being able to interact with faculty and staff. So these are some examples of our best engineering as art winners that we did a year ago or so. Again, these are some sample selected. For example, students in Professor Bosnania group look at the growth of gold nanowires on silicon dioxide. For example, another students look at the basically boron nitride nanotubes modeling and look at the nanotubes. And when you look at this under the electron microscope, you look like this is a dinosaur under a star's light. Next is on looking at the carbon nanotube that looks like a grass. Students, again, grow nanotubes under the microscope. Now with this, I'd like to go to give you a brief overview of a supplement program, or what we call it, certificate, in our Gordon Engineering Leadership Program. That Amy is going to talk about this. And without further ado, I just want to give the microphone to her, and she's going to give you some information about this program.
Excellent. Thank you very much. So good morning, everybody. My name is Amy Manley. I'm the Director of Admissions and Marketing for the Gordon Institute of Engineering Leadership at Northeastern. The Gordon Institute is going into its 12th year at Northeastern, our 12th cohort of students. We were founded back in 2008 by the generous gift of a man named Bernie Gordon. For those of you who don't know much about Bernie, he is known and credited for, owns over 200 patents in the area of the analog to digital conversion. He's known as the father of A to D. He's very passionate about engineering education and has really made it a priority in his career to fund different schools like Northeastern, like MIT, like Tufts, to expand engineering education. Bernie is 90 years old and is still very active. He's actually working on founding a new startup right now, so he's very active in the program and very passionate about engineering education. If we could flip to the next slide, please. So you'll see on your screen our 14 engineering leadership capabilities. I find that typically when students apply to the Gordon program, they're doing so because they are looking to stay technical in their career in engineering, but they also understand the importance of being able to lead teams and lead projects more effectively and more efficiently. So we look to expand you in all 14 of the engineering leadership capabilities you see up on the screen in an effort to help you lead teams more effectively and efficiently. And I'll come back to this in just a few minutes when I tell you a bit about how our courses work. If you could flip to the next slide, please. So what we've found in our market research with companies, with academia, is that there is a gap in engineering leadership education. Traditional engineering education does not explicitly address the key skills, attitudes, and capabilities necessary to equip an engineer to confidently lead a team to success. We find that students coming into our program are smart, very, very smart technically, but when it comes to leading a team and leading a project, 80% of the time, roughly, those projects or those teams fail to deliver a project on time, to spec, and under budget. And we think and know that the reason for that is lack of leadership. Engineers tend to understand the technical stuff really well, but only within a narrow field of expertise. We found a lot of times when you get out into industry, your project may not just be mechanical focused. There could be an electrical component to it, depending on the project. So we aim to give you a high-level overview of what many different engineering disciplines are doing so that you can come out more cross-functional. We also find that product development is lacking a bit, so we're going to give you a deep dive into the entire product development life cycle, and I'll talk about that a little bit further in just a minute. We're really finding that engineers are challenged by the soft skills. How do you deal with a problem employee? How do you initially set expectations for your team and then follow up to make sure that those expectations are being met? So the Gordon program is going to touch on all of those areas. If you could flip to the next slide, please. So you'll see up on your screen the leadership framework. The way the Gordon program works is we replace 16 semester hours of elective coursework within your mechanical engineering degree. Our students all start September, the year they start our program, and they take classes together for the next 11 months. So during the fall, spring, and summer semester, you'd be taking the same classes together with the same cohort of individuals. The way we break it up is into two separate courses. So you'll see leadership capabilities and leadership labs, and product development encompasses engineering leadership. Leadership capabilities and labs are taught by Professor Steve McGonigal, whom everybody knows and loves on campus as Colonel Mack. Colonel Mack is a retired Lieutenant Army Colonel, so he brings a really interesting dynamic into the classroom. He prides himself on he's never given a lecture, he's never given a test. So everything he does is very hands-on, very interactive. It's going to get you up and role-playing different situations with him, with other members of your class, in an effort to improve you and expand you in those 14 leadership capabilities that we talked about just a few minutes ago. The second part of engineering leadership is product development, which is taught by Professor Steve Klosterman and takes you through the entire product development lifecycle, basically from concept all the way to product release. The second class that you'd be taking over the course of your time in the Gordon program is called Scientific Foundations of Engineering. Scientific Foundations is a physics course. It's meant to bring you back to the nuts and bolts of engineering that you should have learned your framework during undergrad, but it's also meant to make you more cross-functional and expose you to different topics in other areas of engineering. We cap all of that off with what we call a challenge project. You can think of a challenge project as being similar to a master's level thesis, but it is a technical project that you do in industry with your employer or with an industry sponsor versus an academic research-based thesis. As you can imagine, all of the challenge projects are very different depending on the student, the company that they work for, how much experience that student has, but they all hit on a couple of main things. So first and foremost, the project must have some market value to the organization that you're completing it for. So that can be characterized by a cost savings, a process improvement, a new product development, something that means something to that organization. It has to be technically deep, in your case from a mechanical engineering standpoint. When you present your project at the end of the year, you're presenting not only to Gordon faculty, but also faculty from mechanical engineering that are going to be looking to see that you really overcame a very difficult technical challenge. And lastly, you have to have the opportunity to show leadership on the project. You don't have to be leading a team of people, but when it comes to that specific project, you are lead. We cap all of that off with a three-way mentoring system. So as part of the program, you're assigned a Gordon mentor and a faculty advisor whose background and experience is most closely related to the project that you're working on. So it allows you to get mentoring from different areas within your project expertise. We also do seminars where each week we bring in a leader from industry to come in and talk to you about their successes, how they got to where they are, and give you advice and share their stories. Excuse me. If you could flip to the next slide, please. So how it works, if you're interested in applying to the Gordon program, there is a separate application process than the one that you may have already gone through within the College of Engineering or are about to go through. You can find the application link via our website. We do also require admissions interviews before admitting you into the program. In most cases, your course load will be split into 16 semester hours of credit within the Gordon program and 16 semester hours of technical courses within your degree. With the exception of two concentrations, mechatronics and thermofluids, which would be 20 semester hours of technical courses and 36 semester hours total to graduate with a combined degree. That is all I have for you today. If you have any questions, feel free to follow up via the chat box, and I will be happy to answer those for you. For anyone who is on campus currently and is interested in learning more, there's an info session on Wednesday evening at 5:30, so feel free to come on over to Stearns and join us then. Thank you.
Thank you. Thank you very much. Let me continue with the so I'm finishing up at the graduate student services that will actually start your applications, process your applications. This is a slide that the Graduate School of Engineering is here for you to help you from different, basically the steps of applying, becoming a student, and also clearing you for graduation. So we're going to actually now going to last part of the presentations before we end up with the summary and some wrap-up question and maybe information is on our co-op. So I'm going to turn the slides to Allison Joyce, who's our assistant co-op coordinator in the Mechanical Industrial Engineering Department, to talk about very briefly about the co-op for graduate students and some of the maybe requirements. Allison?
Absolutely. Yeah, thank you. So my name, as Nader said, is Allison Joyce, and I work specifically with mechanical engineering graduate students and also some undergrad students as well. My colleague, Hobson Goulard, works on the industrial engineering side of things. Can we skip to the next slide? I'll try and go fairly quickly here since I know we're running out of time. So there is a difference between a co-op and an internship. So co-ops are typically tied to curriculum in some way. For us, I'm going to go over what a co-op, the requirements of a co-op are. Internships are not necessarily connected to your curriculum and tend to be a shorter length of time. So again, this just gives a very quick overview of the difference between a co-op and what an internship looks like as well. Okay, we can skip to the next slide here. Okay, perfect. So this is our cooperative education learning model. So as you can see, it begins with preparation or taking some courses in your academic discipline, then going into activities. So this would be your co-op opportunity, going out and applying some of the different principles and concepts that you're learning in your academic courses out in industry. And then at the end, reflecting on that experience. So not just the technical aspect of that experience, but the work environment, fit, and how everything aligns with your career goals. So again, this cycle could lead you to taking some different classes, getting involved in research, or potentially joining a student organization. So really, it's meant to help you figure out what you want to do when you graduate from your master's program. Can we go to the next slide, please? Great. So a few benefits of cooperative education. So again, the main thing is learning what you actually like to do in a job and gaining some experience out in industry, understanding the different roles and different industries that you can work in, potentially post-grad, and of course, making those connections and building your professional network so that when you go to search for a full-time job, potentially after you graduate, you have a whole network of people that you can be turning to as well. All right, let's click to the next slide. Trying to go fairly quickly here. So this, at the top, you can see is our College of Engineering co-op team. There are now over 23 advisors, and we're still growing. Our main role is to help students navigate the co-op process. So finding your process or finding your co-op and then helping you to go through all of the steps that you need to take to really make that co-op a reality for you. So really our role is working one-on-one with students and getting to know your goals. So there are some requirements, as you can see up on the screen currently, to be eligible to co-op. So in the mechanical program, it's a minimum 3.2 GPA. The TOEFL score is a minimum of 95, and IELTS is a 7. And then students also, if we flip to the next slide, must take a course. It's called, we're going on a different thing. It's called ENCP 6100. So that's really where you'll get all your information about co-op. So this is really just scratching the surface here. So these are pictures of some of our students out co-oping. We have grad students who are really all over the country currently. I have one student who is at Tesla at the new Gigafactory in Nevada, an ME grad who's out there working. So really lots of hands-on work. Our students are integral parts of the engineering teams that they're working with. So again, really awesome opportunity to apply the knowledge you're gaining in the classroom out in industry. Let's go ahead and flip to the next slide if possible. So these are just a very select sample of some of our co-op partners that we've worked with in the past. And then if we go to the next slide. Awesome. So again, ENCP 6100 is the co-op course where you will gain information about the co-op process and really how to navigate it. So I didn't want to go too in-depth here. More than happy to answer any questions moving forward though as well. That's all I have for you all today about co-op.
Okay, thank you, Allison, for your time and important information. So for the current students, actually, we have a session which is called orientations, that we go through all of these in more detail and then even talk about the courses that Allison mentioned and also some other requirements. But I just want to make sure that everybody understands that we have co-op for almost all of our engineering programs in the graduate level. That means that regardless of your program or concentration, you can do co-op. Allison was just coming and presenting her role as an ME advisor, but she's representing a very large number of co-op faculty who actually are helping other students also in other programs. So that means that MS-IE, MS-OR, MS Data Analytics, and MS-ME will all have be able to do co-op based on their program requirements. So there's no question about this. So the other thing is that before I go to the wrap-up is about the questions about the admissions and the timeline and all these things. All master's students are reviewed every 2 weeks or so in our department. So every about a month or so, we'll have decisions posted. So that means that if the master's students apply within a time frame, in about 1 to 2 months, we should be able to have the decisions, especially before the deadlines, before like the starting of the semesters, we'll have the deadlines. For PhD, it is different. PhD works with the faculty, has to have a champion from faculty. So that means that before we accept the PhD students, we have to make sure that there's a faculty interested in that student. So once the PhD students applies, if they're admissible to the department, we'll actually take their applications and then run it through the entire department, and interested faculty will look at this. So that will take more time. Sometimes faculty will actually get the applications and then contact the individual through different means to find out more information about the applicant. So for the PhD, I would strongly advise to be patient. Unless this interaction is not built, there is no meaning for accepting a PhD student without having an advisor. So that's a different story with the master's. So with that, I think I'm going to give the floor to back to Kelly to talk about the last few slides.
Great, thanks so much, Dr. Jalili. So we're just going to very quickly go over the tuition and address some of the questions that have come up during this morning's webinar. So the tuition for the 2017-2018 academic year is $1,523 per credit. A typical master's program is about 32 credits. And there are $500 in student fees per year, and each student is eligible for health insurance. And one of the important things when we talk about financing your education is to understand that this is really an investment in your future. So we understand that the cost of education is high. We work to offer funding wherever possible. As Dr. Jalili had previously mentioned, the majority of PhD students do receive funding, and we have a variety of options available for master students, for which our admissions team would be happy to talk with you more about. These are some examples of ways that individuals fund their degree. PhDs can go through fellowships and assistantships. There is cooperative education, which Ali had mentioned previously, are paid positions. Individuals contribute with their personal or family funds and occasionally through private loans. And at this time, I will address some of the questions that have come through this morning and open the floor to any individuals who would like to send questions via the chat feature. So many of you have asked about the deadlines and when decisions will be made. The deadline for the spring 2018 semester has closed. It was September 15th for international students. If you are a domestic candidate for the spring 2015, you may apply by the November 15th deadline. And the faculty are currently reviewing both master's and PhDs, and we hope to publish those decisions in the next 1 to 2 weeks. We do push a priority to international students as we want to make sure that we adhere to the I-20 deadline. For those of you who are applying for the fall 2018, we encourage you to have your application in by January 15th, 2018. And we do review all of those applications once the deadline is closed. So at this time, I will open the floor. We'll hang on the line if there's any additional questions. I'm going to put our microphones on mute, and we'll stand by if any of you have any questions. Thank you again for your interest in Northeastern University. For those of you who have been accepted for the spring, congratulations. We're excited to welcome you to Boston. And for those of you who are submitting your applications for the fall, the admissions team and Dr. Jalili and our co-op and our Gordon Engineering leadership team are here to answer any questions that you have. Thanks again, everyone.